Welcome, this is Mouse Gunner, and in this video I'm going to explain how a flintlock firearm works. The main focus of this video is going to be the function of the lockwork and the basics of flintlock operation. And although the particular example I'm using in this video is a pistol, the same principles and mechanisms will be found on a larger musket as well. Unfortunately, the program I use only has one example of a firearm that uses a flintlock mechanism, and the model in question has some inaccuracies and anachronisms with the way it is depicted, mostly in the ammunition and the loading procedure shown. Most flintlock firearm designs can be broken down into three component groups: the barrel, the lockwork, and the stock. The barrel is going to contain the projectile as well as the main powder charge, which is going to drive the projectile down the barrel. The barrel in this particular example is smoothbore, and what that means, if we come back out into the X-ray, is that the interior surface of the barrel is completely smooth and straight walled. There is no grooves cut into it to impart stabilizing spin upon the projectile. This is known as rifling. And instead, the only stabilizing feature of the barrel is going to be its length. Usually speaking, with a smoothbore firearm, the longer the barrel is going to be, the more stability or accuracy you will get. So in the case of a pistol like this, the barrel's not particularly long, so it's not going to be anywhere near as accurate as a full-length musket would be. The stock is mostly an ergonomic feature that is designed to not only bring all of the different parts together, but also give the user a way to easily manipulate the firearm. The lockwork consists of a number of parts that all work together to ignite the main powder charge within the barrel. So let's identify the lockwork parts as they are in action, chronologically starting off with the interaction between the trigger and the sear. So as the operator of the firearm pulls back on the trigger is going to pivot. And as it pivots to the rear, down here at the end of the trigger, it's going to pivot upwards in the back here. It's going to pivot along this point here. There's a pin that's driven through it, and that's going to be the axis point of the pivot. And as the trigger pivots up in this end, it's going to push upwards on the sear. And as the sear is pushed upwards on, it's going to come out of the notch, and this part here, which is known as the tumbler, and the tumbler is directly attached to the hammer, and the sear itself is screwed into the lock plate. So let's go ahead and take a look at the lock plate. So this is the lock plate. Most of the parts of the lockwork are going to be attached to the lock plate. So you can see several of the screws here are attached in the lock plate. The hammer itself is in between the lock plate and the other side of the lock plate. So most of the lock work is going to be attached to this. Pretty much all of it is going to be attached directly to this lock plate. So let's come back right into the action. So as the sear pivots, because it's being pushed up on this end, it's going to come down on the other end along the axis point of this screw, coming out of the notch in the tumbler. And when it does so, the flat spring here is going to pull down on the other end of the tumbler, and this is going to drive the hammer forward. As the spring pulls down, it's going to bring the hammer down around with it, and at the end of the hammer we have this vise-like mechanism, and that's going to clamp in the flint. And what we're going to have here is interaction between the flint and steel, and when you strike flint on steel, you're going to have the creation of sparks. This is going to be used for the ignition of the primer charge. So if I come out a little bit into the X-ray, we can now see the frizzen, which is going to be the steel part here, which also forms a cup, which is going to cover up the pan. The pan is what is going to hold the primer charge. We'll see the primer charge here in a little bit as the hammer comes forward. So the flint is going to strike. This is going to start to create sparks. And because of the angle of the frizzen, this angle is very important because it's going to push the frizzen up and out of the way. If this was just straight, it wouldn't really have that interaction. The flint would just strike it, and it wouldn't really move the way we'd want it to. Instead, we're going to have kind of a camming action. The hammer or the flint is going to slide down this slope and push the frizzen up and out of the way, and the frizzen is going to pivot along this hinge here. So as it pivots up and out of the way, it's going to uncover the pan, which inside the pan we're going to find the priming charge. This is a separate charge from the powder charge, the main powder charge inside the barrel. And as the sparks are being created with the interaction of the flint striking the steel, Those sparks will now enter into the pan, and ideally, we're going to see it ignite the primer charge in the pan, as we see there. Now, how it's going to get inside the barrel is this hole here. This is known as the touch hole. It is a hole that's drilled inside the barrel that's going to allow the burning primer compound to go into that little hole, vent inside it, and ignite the main powder charge. You do have some problems with this interaction, both from a reliability standpoint and a usability standpoint. Reliability-wise, the sparks can fail to ignite the priming charge is one possible outcome. And in this case, all you would have to do is just restrike. So you would recock the hammer and then replace the FRISM and just go again and hope the sparks do ignite the priming charge on your second attempt. Another thing that can happen is what is known as flash in the pan, which is a phrase that is still used today. And this is where the priming charge in the pan goes off, but it doesn't transfer properly to the main charge, and you don't have your main ignition. So this is a little bit more tricky because you would have to not only recock the hammer, you'd have to also reprime the pan, then close the FRISM, then you would be ready to fire. So it can be a little fiddly sometimes to get going. The other problem with this design is what is known as lock time. So this is the time between when you pull the trigger and you actually have final ignition. So you pull the trigger, the hammer falls, it creates these sparks by striking the FRISM. The sparks come in, they ignite the priming charge in the pan, and that transfers over to the main charge in the barrel. This takes time, and that delay can actually throw off accuracy if you are not being able to steadily keep your aim on that entire time. With that being said, there are advantages to this design, and I'm not really going to get too much into that in the course of this video, but just said simply, it is a simpler design when compared to things that came before it, which made it cheaper and easier to manufacture, and it had decent weatherproofing. The FRISM forms a nice seal for the priming charge as well as the main charge, making wet weather not too much of a problem. But when later developments came where you had percussion caps as your main ignition system, the flintlock mechanisms were quickly replaced. To wrap things up, I'm going to go over a couple parts that I haven't talked about yet, just to give a thorough explanation of how the mechanism works. And the first part we'll take a look at is this spring here. So it's a V-spring, and its job is to put tension on the FRISM. And the reason it does this, if we go back into the closed position, is to retain it in either the closed position or the open position. So right now it's in the closed position, and the spring is putting tension here on this lobe, and by putting tension on it is pushing up this way. And because it's pushing up this way, we have, through pivoting action through this axis point, force also being applied down this way on the FRISM, which is going to keep it closed. And the importance of that is you don't really want your FRISM flopping around on you and opening up when you don't want it to, or maybe moving out of the way of the contact of the oncoming hammer. So that's the importance of this tension. But when the force of the hammer driving the flint comes in, it's going to overcome the spring tension. The spring is going to be pushed down, and as the FRISM comes around, it's going to come beyond this hump here. And once it does that, the spring's going to come back up and again put tension on the FRISM. And it's going to do that in this direction up here. And that, by putting it in that direction, it's going to in turn put force to retain it in this direction. So that will keep the FRISM held open, which is going to give you easy access to the pan so that you can put another primer charge in there without it really obstructing you. So it does double duty there, retaining it when it's open and retaining it when it's closed. And the last part we're going to take a look at as part of the lock work is the sear return spring. You've seen this already, but you might not have understood exactly how it worked. So as the trigger pushes up on the sear, it's going to compress this V-spring. And when that force is taken away, the operator of the firearm is no longer putting pressure on the trigger. What's going to happen is this spring is then going to push down on the sear, which in turn is going to push down on the trigger, resetting both. And we'll see that happen there. So you can see the spring is pushing down, releasing its tension, and that in turn is pushing down the sear, which is also driving the trigger into its normal position. To begin the rearming process, the user of the firearm is going to first need to bring the hammer to the rear, but they're not going to bring it fully to the rear. Instead, they're going to put it in a halfway position known as the half-cock position. And this half-cock position happens to be a notch in the tumbler, this first notch here. Previously, we were using the second notch, which is the full cock position. This is the position you'd want to put the sear in when you are ready to fire, as a trigger pull will drop the sear out of this notch and bring the hammer forward, as we've seen before. But when we come into this first notch, the half-cock position, we'll see that there's this material here on the tumbler that hooks into the sear, making it much less likely for the sear to slip out of the position, making it a lot safer, but also making it a lot harder, pretty much impossible, for the trigger pull to also drop the sear, because as you pivot up on the sear on this end, the sear tries to go down and it can't because of this hook here. So to get the hammer to be able to come forward, the user of the firearm needs to bring the hammer back just a little bit, enough so that the sear comes back out of this notch enough so that it can come down freely. The user of the firearm can pull on the trigger, and they can either manually bring the hammer back down to the uncocked position if they wanted to, and if they didn't want to, they don't necessarily have to pull the trigger. They could just bring the hammer all the way back and then put it into the full cock position. So that's what you would need to do to bring the sear out of this half-cock position. Now, the reason you're going to put the hammer in this half-cock position is mostly just to get it up and out of the way in a nice, safe position so that you can start the rearming process. You have nice, easy access to the pan. It's not going to be in the way of that, so that you can do the rearming process. Now, I'm not going to show the reloading process in this video because I don't necessarily agree with the way that they do it in this program. So instead, I'm just going to quickly explain the process to you. Once you have put the firearm in the half-cock position, you are going to pour the main powder charge down the muzzle end of the barrel. This is why firearms of this type are referred to as muzzle loaders, because you load from the muzzle end. And the reason for this is, although the barrel is a hollow tube, in a muzzle loader, it's closed off with a plug at the back, and we can see the plug here. So if I zoom in here, you can see that this is actually a separate piece of metal. You can see the seam right there. And the purpose of the plug is just to form a gas seal on the back to prevent escaping gases from going to the rear, and instead focusing those expanding gases towards the front, pushing the projectile down the barrel. Once you have loaded in the main powder charge, you're going to follow that with a patch and a projectile, usually a spherical ball. The purpose of the patch is to form a nice gas seal, because the projectile, the ball, is usually going to be a smaller diameter than the bore. And the reason for that is just for easy loading. It's a lot easier to load a smaller diameter ball down the barrel than it is one that is going to be a tight fit. And that is why you use the patch, because it's going to form around a gas seal for the undersized ball. Once you have done that, you're going to ram it home with the ramrod. You don't have to use a lot of force here, because again, the ball is going to be undersized. You just need to push it down gently up against the powder charge. And once you have done that, you're then going to prime the pan, close the frizzen, and put the firearm on full cock when you're ready to fire it. If you're going to be carrying it around for a while, or you're not really sure when you're going to want to fire it, you might want to just keep it on the half cock position until you're ready. But when you're ready, bring it into full cock, pull the trigger, and we're ready to begin the process again. And that wraps up my video on how Flintlock firearms work. The focus of this video was predominantly on the mechanisms behind the functionality of a Flintlock firearm, but it is not meant to be an end-all be-all of all the information that you would need to know about a Flintlock firearm, in particular if you're interested in running a Flintlock firearm. If that is a subject that you're interested in, I'm going to provide the link to a couple of channels that have a lot of detail on black powder era firearms, covering muzzle loaders as well as other repeating firearms that use black powder as well. So if that's a subject that you have a lot of interest in, I'm going to include those links in the description. In any case, I hope you guys have enjoyed the video. This is Mouse Gunner, signing out.